Hello guys, welcome to the channel. I hope you all are fine and doing great. Today we are going to discuss this counting elements into array problem of GFG. So let's move on to the problem guys. Here we are given two unsorted array named as ARR1 and ARR2. Like you can see here, M is the number of element in our first array, N is the number of element in our second array. They can be same or different. Like here, first element contain only 5 element while second one contains 7 element. Okay, so the number of element can differ. Okay, and the array may contain duplicates as well. Like here you can see 1 1 is duplicate, there is 3 1, there is 2 1. Okay, so means duplicacy is allowed. And now for each of the element in ARR1 we need to find out the number of element less than or equal to current number of our ARR1 in ARR2. Like I am explaining you, like the current number of our ARR1 is A, current number is X, and this is our A2 array. This is our A2 array. Now in this A2 array we need to find out the total count of the number which are A to I, means second array ith element, less than or is equal to X. We have to find the count of these number less than or is equal to X. Like for 1 we have 4 element, 1 1 1 0, 4 element less than is equal to 1. Now for 2 we have 5 element, for 3 we have 5, and for 4 7 and 9 we have all the 6 element less than or is equal to respective 4 7 and 9. Okay, so guys, we need to find out now how can we do it. Okay guys, now how can we do it? Just a minute, I just open my code, either I need to write it. So one way of doing this is like, for each number 1 I will traverse a loop from 0 to n minus 1 and check if this is less than x or not. But this is n square time complexity, this is n square time complexity, and we have to go time complexity of into log and something. So when there is searching, like you have to searching a range of number in this array, so the first thing come to your mind is binary search, because you can reduce your complexity from on to o log n if you are using binary search. So we will go to use binary search. Now how I will use binary search, just a minute. Okay guys, so I am explaining for this number. First of all, yeah, okay guys, so these is the array given to me. Like I will update my ARR2 and I will sort it. Why sort it? Because after sorting in n log n, my time complexity will remain in n log n something. So I will sort it, and after sorting it will look like 0 1 1, 3 times 1 0 1 1 1 2 and 4. Okay, 2 and 4. So I can say my array will look like, just a minute, just give me a minute. As this is a very simple problem, if I am doing this by like this: index 0, index 1, index 2, index 3, index 4 and index 5 element are, I will change the element color to blue. 0 1 1 1 1 2 and 4. This is my sorted array. Now guys, what I will do, for 1 I need to find out how many number are less than or is equal to 1. How many number are less than or is equal to 1. Okay guys, so there is a function upper bound. There is a function, like we have sorted the array, second array, and take a vector of int, because we have to return the count of element for each ARR1 number. Now for all the number of ARR1 from 0 to m, I will take current number is ARR1 I, and we will take some count now, like how many number are smaller, and push back it in our answer and return answer. Now this is the main statement on which we have to work. Now there is a function called as upper bound given to us that will tell us the index of what this upper bound do. It will gives us I of number, I of the first element which is greater than current element 1, index of the first number that is greater than 1. So like what is the index of first number that is greater than 1? It is 2. So it will return as 4. Now we can see we have 0 to 4 minus 1, that is 0 to 3 index number which are less than or is equal to 1. So how many total number we have? 4. Okay, or we can say the index it will give is the answer because it is 0 based indexing. So total number we have is 0 to I minus 1 is equal to I. Okay, so we just push back 4 in our answer. So our first number is 4. Now for this 2, it will gives us first index that is less than or first number, first index in our this array which is greater than 2, that is 5. So we can see 0 to 4 minus 1, I have 5 number less than 2. So answer is 5. Now for 3 as well, it will gives me 5 because 4 is greater than 3 and this is the first index. Again 5. 5 is the index because we just need the count. So count is equal to index because our indexing is 0 base. Okay. Now 5. Now for 4, it will return us. For 3 we have completed. For 4, it will gives us the end of the array. Okay, it will gives us the address of the current array, and what we are doing, we are decreasing the starting array to here. The array name means the starting address of my array. Like this have some address x, uh, this have some address x. So this have some error x plus something, x plus 1 or something. So if you decrease the starting address from this upper bound function, then you will go to the index of the current value. So you will go to 6, means you have 6 number that are greater than is equal to that are less than or is equal to 4. So you will push back 6. Now for 7 and 9, it will also return me 6. So 4 5 5 6 6 6 is my answer. Similarly guys, here you will solve and find out. So this is upper bound, just a simple function. So this is how we will do this problem using binary search and reduce our complexity from n square in linear search to n log n in binary search. Okay guys, so here you can see all the 432 test cases pass out. I hope you all understand the problem. If you have any doubt, then just comment out. I will try my best to explain you. Please subscribe the channel, like the video, and if you understand the approach, please comment out, as it will motivate me to make more this type of content. And now we will regularly update the problem because my placement season is over. So I am free now. So I will again start to upload the problem solutions. So thank you for watching this guys. Stay tuned.